Welcome back. Currently, we have some failing tests around the difficulty requirement for mining a block, as well as the nonce value, which are both crucial parts of the overall proof of work system. To begin, let's get the nonce and difficulty property tests to pass by adding the nonce and difficulty properties to the block itself. So in the block.js file, let's add new fields for the nonce and the difficulty. And then we'll set those as the last lines of the constructor itself. So we have this not nonce equals nonce, and then this dot difficulty equals the incoming difficulty. Cool, so that takes care of one failing test, which enforced that the block has a nonce and a difficulty field. Next, we need to make sure that this generated hash should be based on also the mined block's nonce value, as well as the difficulty. Again, the difficulty defines how many leading zeros a valid hash should have. Now, the initial difficulty of the system needs to start somewhere though. And where better to start the difficulty than in the Genesis block's properties, which is the first block in the overall system. So we're going to set the initial difficulty there. The Genesis data is defined in the config.js file. So let's define an initial difficulty constant right at the top. So we're going to have an initial difficulty. Make sure I spell initial difficulty correct. And let's make it 3, which isn't rather high, but we want this to be pretty low while we're developing, so that way it doesn't take forever to add a block. Like, we don't want to wait 10 minutes as we would have to mine a block in blockchain, or rather in Bitcoin. But in our blockchain, we're going to make it pretty low. So now this allows us to set a difficulty field for the Genesis data. So we're going to have a difficulty part of this block after the hash part, and this will be set to the initial difficulty. Likewise, we're going to set a nonce field, which can be anything. So for now, let's make it the lowest value 0. All right, cool. And the idea is that now that we have an initial difficulty within the Genesis block, every block thereafter can base its difficulty on the block that came before it. So the first new block that is going to be added is going to share this difficulty of 3 because it'll reference that from the existing Genesis block. So in block.js, let's grab the difficulty of the last block and set a local difficulty variable by destructuring that. So overall, the syntax is const curly braces, difficulty in the curly braces from the last block constant. Likewise, we're going to set a local nonce value of 0, but we're going to make this a dynamic variable since we want the nonce to be able to adjust while we're going through a mining block algorithm. Cool. And now we'll apply this difficulty and this nonce within the block that we're creating. So right before the hash, let's also apply the difficulty and the nonce, since those are fields within creating a block itself. Great. Another thing we want to take into account is that the crypto hash should also base it on the nonce and the difficulty, since those are parts of the block, and we want to include that when we're creating a hash for an entire block and all of its fields. As we save this, you'll find that other tests are now failing when it comes to the blockchain.test.js file, and it all relates to validating the chain. So something we changed here affected how our isValidChain method is working. So if you head to blockchain.js, you'll notice that we have this validated hash portion. But right now, the validated hash is only based on the timestamp, the last hash, and the data. Well, we just added the nonce and the difficulty, so we need to make sure to get those as well. Let's destructure the nonce and the difficulty from the current block in the chain, and we'll also take that into account when we're regenerating the validated hash through the crypto hash method. And as we save this, well, we should find that our test that is failing is now isolated to the one new relevant test where it sets a hash that matches the difficulty criteria. So our isValidChain method tests are working as before. Okay, so let's focus on this difficulty requirement. To pass this difficulty requirement, we need to introduce a pattern that creates new hashes until one is found with a satisfying number of leading zeros. To accomplish this, we can add a do-while loop that increments the nonce value until the difficulty criteria is met. So first up, let's refactor the hash and timestamp to let variables, since we want those to be able to be reset on every iteration of the do while loop. So the first line of this MindBlock function is actually going to be let hash and timestamp. For now, let's comment out the timestamp and then the hash setting over here. And then we're going to add a do while loop. So we're going to do something within this block of code while a certain difficulty criteria isn't met. So we're going to check whether or not the hash dot substring from 0 up to the difficulty is not already equal to a string of zeros. And we'll generate the string by repeating a character of 0 up to difficulty times. So this is going to be checking that the substring of the hash itself starts with that certain number of leading zeros. And we're going to keep doing some kind of code while this hash difficulty criteria hasn't been met. So as the first step in this do while loop, well, let's increment the nonce value. This will allow the nonce value to be changed on every run of the loop. Likewise, we want the timestamp to be accurate according to when the valid hash is found. So we'll create timestamp to date.now. All right, and the next thing is to create the hash, which we'll do by calling the cryptohash function and pretty much inputting the same fields that we already have below. So the timestamp, the last hash, the data, the nonce, and the difficulty. Except the difference is that at every iteration of this do while loop, this nonce is adjusting. Therefore, the hash gets a chance to regenerate a new value that'll hopefully meet the difficulty criteria that we're enforcing here within the condition of the while loop. Great. Let's also make sure this hash is included. I'll use Command D to place this all on one line. Cool. Take out the commented out code as well, which includes this const timestamp. And as we save this, well, we should find a fully green passing test suite once more. Cool. So with these changes, or rather with these changes, we've now satisfied the requirement that each block should meet a level of difficulty when generating its hash. The higher this difficulty gets, the more computational power it will take for a miner to actually add a block to the chain, because they're going to have to generate more and more valid hashes in order to find that valid block. But right now, since every difficulty is based on the last block, the difficulty is going to stay static throughout the entire system. We want this difficulty to be dynamic. So this will allow the system to self-adjust according to a certain mining rate that we want new blocks to be added to the chain. In other words, if a block is mined too quickly, well, we should raise the difficulty and make this requirement harder to meet. Otherwise, if blocks are mined too slowly, we'll lower the difficulty overall so that way it's easier to meet the difficulty requirement. So this constant difficulty adjustment will ensure that on average, blocks are added at a reasonable pace. Okay, let's tackle that next.